Hi, good afternoon all. My name is Naresh Kumar Muttakoduru. My project is optimizing machine learning models data analysis. Next, introduction. And today we are sharing insights from our research on optimizing machine learning models across diverse datasets. Our focus has been on evaluating model performance, understanding the strengths and limitations, and offering recommendations for real-world applications. And the methodologies overview are the researcher followed that CRIPM DIM framework, and there are some of the frameworks are there like business understanding, data preparation, modeling, evaluation, and deployment. Next, the dataset overview is like we examine three distinct datasets like bank dataset, mushroom dataset, and coupon dataset. Each dataset presented unique challenges and opportunities for model evaluations. Like the bank data sets we gained has 41,188 records of 21 variables, and these may contains 10 numericals and 11 categories data columns. And here that the data dictionary in bank data sets are like the demographic, employment and education, credit and housing, like contact details, campaign details, and economic indicators. So these are we have taken in the bank data sets. And in mushroom data sets, we have taken like travel and demographics like destination and passenger details and coupon and expirations and information and preference for dining places and travel direction, temperature and numeric values, contacts with bar and restaurants, and target variables. We have taken in like that. And in mushroom data set, we have taken like class and like characteristics like cap, brushing, bleeding, and gale characteristics, stem, well, ring characteristics for print and environment. And data preparation. To ensure robust modeling, we conduct through data cleaning, handling missing values, encoding, and even employed principal components analysis. For dimensionality reduction, where applicable. And here the model analysis, logistic regression, like uh, utilized for its interpretable and good performance in the bank datasets. Like this is the graph we have inserted in this model, and we can assume that uh, as per the model. And k nearest neighbors like display strong accuracy across the datasets, and we have taken like class A, B, and C. Throughout this, we have the this is the graph, and this is the k nearest neighbor neighbor neighbors. And in this known as and this is known as the supervised learning method, which is based on finding k close uh, samples in the attribute space. Big data classification is very slow when using the traditional machine learning classifiers, particularly when we using a lazy and slow by nature. The classifiers such as the k nearest neighbors as focused in his paper, scaling the traditional Canaan model into the applications of the big data models. Due to the simplicity, easy understand, and relatively high performance of KGM. And this is the decision tree. And these we have showed a promising performance, but with the variations across the data set. We can assume the data sets which we had taken like this, and we can see in the graphs like about the this. And this we have taken like for the machine learning model, it is easy to interrupt, and it employs recursion binary participation algorithm that splits the sample in a participating variable with the strongest association with the response variable. The process continues until some stopping criteria are met. The predictions of the events is made from roots of leaves as per the terms. This tree is made up of the decision nodes, branches, and leaf nodes, and this tree is turned into upside down, and all categories are mixed in at the root, represented the original data set. And the model will be trained on the data, and from its fit to the first decision tree model, the tree depth without optimizes turning the model by adjusting the max depth parameter using grid search. And this now is bias exhibiting limitations in handling specific data sets, notably the mushroom data sets. And this is a graph we have taken like this, and you can see, and as you can see that, and random forest and xgboost demonstrated constantly strong performance across the most datasets indicates their robustness. And there are the two uh, graphs we can see in this page, and we can see like a new sample and a result one, result two, like it's like in a decision tree with a full of nodes, and we can assume there are so many of the results which like nodes. And the other one is like assume assemble classifier, like there is the original data and bootstrapping, aggregating, and bagging, and these are all we can include in this. And next, model evaluation. For each dataset, we evaluated the models based on F1 score, score. And these models are varied regarding the classification models, and chooses the logistic regression of the best model for the bank mushroom datasets and random forest for the best model for the coupon dataset can be attributed to characteristics of the data sets and the strengths of the respective algorithms we can get in the in this insights. And and this conclusion is our research highlights the variability in a model performance across data sets. Factors such as class imbalance significantly impact model training, particularly in the bank datasets. While certain models performed exceptionally well, others exhibited limits based on the dataset characteristics. And class imbalance affects the model training. Like in the severely unbalanced bank datasets, accuracy is much larger than F1 score as compared to the mushroom and coupon datasets. And here the recommendations, like our recommendations are tailored for each datasets. Bank datasets like focused on logistic regression and XG model. XGBoost address limitations in KNN model, and Navi Bayes and decision trees. And mushroom datasets like Perdis, Random Forest, and XGBoost reconsidered Navi's Bayes suitability. And like lastly, coupon datasets. All model perform exceptionally well. Explore fine tuning random forest and XGBoost. And these are the external data sources, and we have included, and internal predictability and ethical consideration. And this is the project we have done. Thank you.